Assalamualaikum and good afternoon to Dr. Goh device. Distribution switchboard include the main low voltage switchboard are critical to the dependability of a electrical installation. A distribution switchboard is the point at the which an incoming power supply divided into a separate circuit, each of which is controlled and protected by the fuse of circuit of the switchboard. The low voltage is the upper-story terrace house used in 3-phase 4-wire 415 volts and up to 40 kVA in maximum demand.
So basically, I will explain the methodology part for the project. Okay, firstly, in order to calculate this total connected loads, we have to define the quantity of the equipments used in the house. Next, after we obtain the TCL or the total connected load, we will determine the maximum demand as well as the current maximum demand to obtain the suitable value for MCCB and the cable size. Maximum deals with the demands that we need in the electrical wiring, so that we can assume here we must assume that all loads are not used simultaneously, which is in contrast with the TCL value before. So when we have obtained the maximum demand value, we must add a 20% of value for spares, and we also must take into consideration the fact that there will be additional loads in the future. So value of TCL or total connected load calculated for one circuit for the lamps and fan must also not exceed 1 kilowatt for MCB with the rating size of 6 ampere. This is because the minimum breaking capacity for these MCBs are 6 kilo ohm. After we obtain the size of RCCB that will be used for the house equipment, we will determine the size of the cable that we need to use for the lighting circuit. So this size of cable will also determine how much this rating differ on types of the switch socket that we will use. So there are several factors that will affect the size of cable in choosing the size of cable. So basically, first, the total connected load connected to the circuit, which is the overall circuit for the house, and then next we will take into consideration as well as for the rating of the protective device such as fuses, the MCB, the RCCB, the MCCB, and then we will also take another factor that will also influence the size of cable is the voltage drop for each cable.
Okay, next we go to the plan for the house. We have two type house, which is type C and type C2. Okay, type C2 consists ground floor and first floor, and the type C2 also consists ground floor and the first floor. Okay, based on the house plan, we design the circuit which is a 3-phase circuit, red, yellow, blue. We design the circuit that for the circuit breaker and for the power supply that you will use. Okay, this one we design for the type C first floor and type C ground floor. This design we design in the AutoCAD. We design that the design contain for the fan, lamp, heater, and for the air conditioner. Same goes to the type C ground floor. And then for the second house, for type C2 ground floor, we also design in the AutoCAD the same concept, which is three-phase communication. So for the C2, the house is about the same with the C house. So we design the use for the lamp, fan and heater is almost the same with the C house. Okay, this basically the design for C2 and C house is almost the same. So for the calculation part, I will show how the design work.
I will explain the calculation part. First, we have to calculate the total connected load. To get a total connected load, we add all the total power of all the electrical load in the diagram and get the total connected load. To get the total power, the estimate power of the particular electrical load multiple to the number of load. Second, we calculate a maximum demand. First, we get power PMD is equal to PCL times DF, and then we get PMD. Then we find the I single phase is equal to PMD divide V cos theta. Then we find the maximum total load current in three phase. Current in three phase is equal to PMD divide SERT3 times VLL times cos theta. Third, nothing for protective device. We find the total current per phase of all phase like R1, R6, R7, Y1, Y6, B1, BC, B7, and so on. To get the total current per phase, total power of load in particular phase will add and then divide V cos theta. We get the current value. Fourth, determine the size of cable and total demand load. First, we have to find the apparent power. Apparent power S is equal to total power over power factor, and then we get the S value. To find the demand load, apparent power S times DF to get the demand load, and then we add all the load and get the total demand power. To find a current is equal to kVA over kilo kV times SERT3. Then we get a current. So the value current we get is 36.34. So the circuit serving the panel board will be protected by 100A TPN MCCB. For the type C2, all calculation same as type C, but the C2 have no wall fan point, but the last current is same as type C. Also, we use the panel board will be protected by 100 ampere TPN MDC.
For the conclusion, the objective of this project, which is to disseminate the knowledge of designing an electrical schematic diagram for residential building to students in practical environment, was achieved. Furthermore, after our group have completed the projects, our group should be able to, first, to design and analyze a comprehensive electrical schematic for residential building system. Second, our group can identify appropriate safety concerns that comply with standard wiring regulation in designing the low voltage electrical distribution system. Thank you.